Algebra 1, Chapter 3, Section 6, Solving Compound Inequalities. A compound, which is a noun, is a whole formed by the union of two or more parts. A compound inequality, which is an adjective, consists of two distinct inequalities joined by the word and or the word or. For example, you read 3 is less than x is less than 6 as 3 is less than x and x is less than 6. You may also read it as x is less than 6 and greater than 3. There are a few symbols we can work with to show this. A compound inequality consists of two inequalities, and they are connected either by an and, which we symbolize by this, or by an or, which we use this to symbolize. Because inequalities are sets of numbers, we can look at both the union and the intersection of these sets. Example, x is between 0 and 4. So we're looking at the union of x is greater than 0 and x is less than or equal to 4. Well, since x is greater than 0, we have an open circle there because that's a less than sign. And when x is less than 4, we're going to have a closed circle because it's less than or equal to. And the value we're looking at, or the values, the set, is in the middle. And implies the overlap. So if we had drawn this without the overlap, we would have had a 0, open circle, and we would have shaded all the way up here. When x is less than or equal to 4, we would have went to the 4, closed circle, and shaded back. So your overlap is this section here where it's overlap, and that's actually the solution. That's the union of the two graphs. In this example, we have all real numbers that are less than or greater than 2. So we look at x is less than -1. Open circle at -1 because there's not an equal sign, and x is less than it. We also have x is greater than 2. So at 2 we have an open circle and we look at the sides greater than. So our solution here does not have an overlap. There's no intersection. So this would be a union of these two values. Looking at this example, we have a compound inequality, and we want to solve this. And this needs to be in your notes, number 2. First one was vocab. So to solve and graph this, we need to first realize that the two inequalities are joined by and. And then we need to separate them. So we're going to first look at this inequality, and we're going to put it over here. And then we're going to look at this inequality, and we're going to put it here. So let's go ahead and do that. So here's the first half, and here's the second half. Now, we're going to go ahead and solve these as two separate problems. So we're only going to work on the left side first. So on the left side, to isolate this, we're going to add 4 to both sides. Remember, this was -2. So -2 plus 4 is 2. -4 plus 4 is going to cancel out, leaving us 3y. So we have 3y is greater than 2. Divide by 3, divide by 3. So we have 2/3 is less than y. So on the left we have 2/3. Now looking at the right side of the equation, this was the second one, remember, we are going to look at 3y. Let me go ahead and do that in red so it might make a little more sense to you. So on the left-hand side we have 3y minus 4. And to get rid of the -4, we're going to add 4 to both sides because we still want to isolate the variable. So this is going to cancel, leave me 3y. And on the right, I'll have 14 plus 4, which is 18. So I have 3y is less than 18. To get the y by itself, I need to divide by 3. So y is going to equal 6. So, I'm sorry, not equal. Y is less than 6. So notice here I've used the addition property of inequality, the division property of inequality by dividing, and then I did a lot of simplification. So if I was graphing this, I'd have a 0, 1, and then I'd have a 2/3 about right here. 2, 3, 4, 5. Oh, I should have made my line a little longer. 6. And I would graph an open circle here, an open circle at 6, and notice that y is the union of both of these. So y is all numbers greater than 2/3 and less than 6. But my union, my shaded area here, is what my solution would be, including open circles at both ends. And let's try one. Feel free, if you're feeling confident, to go ahead and pause this video and try this problem. But like previously, I'm going to look at two separate problems. The first one is going to be -2 is less than or equal to 3x minus 8. Then I'm also going to look at 3x minus 8 less than or equal to 10. I'm going to solve both individually and then put them together. This is a compound inequality. To solve the one on the left in black, I'm going to add 8 to both sides. So 6 is less than or equal to 3x. Divide both sides by 3. So is 2 less than or equal to x. Now I go to the next problem. I'm going to add 8 to both sides. So 3x is less than or equal to 18. Divide by 3, divide by 3. So x is less than or equal to 6. So my final answer is 2 is less than or equal to x, and x is less than or equal to 6. When I go to graph that, that's 2, 3, 4, 5, 6. I probably didn't need quite as big. So my 2 is less than or equal to x. It's going to be a closed circle because there's an equal sign involved. And x is all these numbers greater than this. X is less than or equal to 6. It's going to be a closed circle again. And all the numbers this direction. So my solution is going to be a closed circle at both ends and a union of these two lines. Looking at this, we have an OR statement. So we can easily see this as two separate equations. So let's go ahead and solve them. Subtract 1 from both sides. So 3x is less than 3. Divide by 3, divide by 3. So x is less than 1. And on the right, we're going to add 5 to both sides. So 2x is greater than 12. Divide by 2, divide by 2. So x must be greater than 6. So looking at our graph here, we can have a 0, 1, 2, 3, 4, 5, and a 6. For x is less than 1, we're going to have an open circle at 1, and we're going to shade to the left. For x is greater than 6, we're going to have an open circle at 6, and we're going to shade to the right. There's no intersection here. So this is a union of two equations is a solution. So our solution can fall anywhere in this grouping as well as those that are larger than 6. And maybe a better word than grouping would be set. This is your notes number 5. Okay, this is a compound inequality again. And this one is an and statement, so we need to break it out as such and have two separate problems. We work the problem on the left. We have 0 is less than negative x. So I need to divide by -1. Now, do you remember what happens when I divide by -1? Yes, the sign changes. So we have 0 is greater than positive x. On the right-hand side, I'm going to add 2 and add 2. We have negative x is less than 3. And once again, when I divide by -1 or multiply by -1, what happens? The inequality changes. So when I go along to graph this, I'm going to use my 0. 1, 2, 3, 1, 2, 3. And I'm going to have x is smaller than 0. And I have an open circle at 0, and x is smaller. And then I'm going to have x is greater than -3. So open circle, x is greater than -3. So my final answer, although I've written it all down here, is this spot right here between 3 and 0. And this is my final answer. All the stuff on the outside I have to leave out. So my final answer is this right here in a graph form. This stuff doesn't count as far as my answer goes. Number 6 in your notes. Looking at this, I want you to make sure that you include the word interval notation and realize that there's 3 notations I want you to think about. The first one is brackets, and they're used with less than or greater than, and they indicate the interval's endpoints are included, so we use a closed circle. The next one is parentheses. The parentheses are used with parentheses, and they are used with greater than or less than, and they indicate that the intervals are not included, but everything up to them are. The last notation is infinity. This is a positive infinity. Use it when the interval continues forever in a positive direction. This is negative infinity. Use it when the interval continues in a negative direction. So please make sure those things are in your notes. And I want to give you a minute. You don't have to write this out, but I want you to think about what the correct word or words are to complete each sentence. So in parenthesis -2, 7 bracket, the parentheses to the left of -2 means that -2 is or is not included in the interval. What do you think? You are correct. It is not. But the bracket to the right of the 7 means that 7 is or is not included in the interval. You are correct. It is included in the interval. So in short, this means you can use interval notation to explain your solutions. It should be in your notes. This will be I think it's number 7. So go ahead and write x is greater than or equal to 2. Now in interval notation, that says that x is going to start at 2, and it can include 2. So we have includes 2, but it goes on to positive infinity. Now the infinity symbol always has a parenthesis following it, because you can never reach infinity. So hence it can't be included. In the second one, x is smaller than 2, so it's going to go on to negative infinity, but it's going to stop at 2. Now it does not include 2, so it's not going to have a bracket like that. Instead, it's going to have a parenthesis. Let's try it again, parenthesis, because there's no equal sign there. The next one, we have a parenthesis around the 1 because there's no equal sign in this inequality. But yet if you look at the 5, we're going to have a bracket there because it can include that 5 with that equal sign right there. In the last one, we have x is smaller than -3. Or we have x is greater than or equal to 4. So that's how that will look. And that will have 2 parts in it. If that does not make sense, make sure you're asking me in class tomorrow. I had a lot of information on this unit. So take a moment, look at this, do your best, pause it, and then start this back up to make sure you understand what's going on when I do the correct answers. You realize that this is a correct answer. And why is this wrong? Well, it's wrong because infinity can never be reached. And so it's always going to have a parenthesis. Never is it going to have a bracket. Make sure you understand each of these words and tell me how well you get it.